All right. In the beginning of the year, you were graphing linear functions. That's when you have y equals mx plus b. Okay? If you had a table, the way you could tell if it was linear is you had the same thing being added each time. In other words, an arithmetic sequence in the x value, and you had an arithmetic sequence in the y value. You had a slope. This was always the same, so this slope would be 5, y over x. Quadratic is what we did next, and that was when you have x squared, remember? Not anything times x squared plus something, plus x maybe, and plus the y intercept was your c. Remember a, b, and c? ax squared, bx plus c. All right. How you could tell from a table was you had an arithmetic sequence here, and here you had one, but not until the second time you did it. Now that you know what arithmetic means, we can use those words. Okay? Remember, you did the first time and they were different, and then the second time they were the same. Today we're going to do an exponential function. Okay? Your book likes to use f of x. I just always change it to y. But you don't have to. I just don't like f of x. But when you get into Algebra 2, you're going to need f of x because there's going to be f of x and f of something else on the same, well, you'll see. Anyway, here is an exponential function. The way to tell an exponential function at a table is you have an arithmetic sequence in the x value and a geometric sequence in the y. Simple. Same thing being added. Same thing being multiplied. So as you can see, they climb very fast. So these graphs are going to look weird. And you're going to have to change the value of your y to make it fit. We're going to graph four of them today. You're going to graph 2 of them on your own, and you're going to watch me do 2. And you don't get your homework in your notes until you graph them both right. So for some people it took 2 minutes, and for some people it took the whole period to get it right. But all you have to do is know how to use your calculators. Who does not have a calculator today? You got one? You got one? Okay. All right. Anyway, tomorrow I'm going to show you exponential equations, and you're going to do some tonight, that go with things that really happen. Like here is an exponential function of the population of a flea. I can change the f of x to y if you like. Okay? In other words, let's say x equals days, and it does. This is a real equation, by the way. In 3 days, what would be, see, in an exponential function, the x is always missing. You know how you always made up x and you got y? Well, you're still going to be you're not going to be making up x. I'm going to be giving you x. Okay? I'm telling you x is 3. X stands for days. So how much would the flea population multiply in 3 days? Anybody?
128.
It's 128. A lot of kids wanted to do 8 times 8 times 8. What's wrong with 8 times 8 times 8? Why can't you do that?
They didn't multiply 4 times.
You have to do 4 to the 3rd power first, and then times 2. Okay? But on your calculator, 2, left parenthesis, 4, right parenthesis, caret, 3. In 128 days, not 128 days, in 3 days, it would be up to 128. How much in 4 days? It would jump. In just 1 day, it would jump from 128 to what?
512.
512. They grow fast. Okay. We're going to graph 4 different kinds of exponential functions. They all look like one of these 4. Every one of them looks like one of these 4. Now, I'm going to give you a graph paper without this because you don't know where to put the x-axis yet. Watch how crazy this gets. Get out your calculator so you can practice. If we put 0 in for x, Should be able to do that in your head, but my guess is you forgot what 4 to the 0 power is. So what do you get?
3.
3. Excellent. No, 4 to the 0 power is 1. 1 times 3 is 3. You could probably do the 1 in your head too.
12.
12. Okay, put in -1 now.
47.
No, a negative exponent never gives you a negative answer. Remember, move me, make me positive. What do you get? 12?
I got 0.75.
It's 0.75.
Let me try that.
Put it in your calculator, make sure you can all get 0.75. Now I'm going to show you why it's 0.75, because you just jumped the gun on that 12. 3 times 4 to the -1 power. Okay? That means move me, make me positive. 3/4, 0.75. You don't have to do that. You can just plug it in. Okay, what about a 2?
48.
48. See how crazy the numbers get? You have to graph 2, 48. What about -2? 0.1875. Now, I know, it's crazy graphing, right? But look what happens. Okay, now, since I have a 1, something really big, I'm just going to move my x-axis down. But I got to get to 48, so I'm not going to use 1s. I'm going to count by, I don't know, I got 48 and 12, so I think I'll count by 4s. Okay, that'd be 8, 12, 16, 16, 20, right? See what I'm doing? No, I did something wrong.
You went
That's
16
24.
foot.
I'm counting by 4s, but I'm only writing down the 8s.
Skip 12.
I skipped something? 12, 16, 20, 24, no I didn't, 28, 32, 36, 40. You don't need to write them all in. And then 44, 48. Okay, I'm good. Here you can leave it alone because we're always going to use these 5 numbers. You can go to 3 and -3 if you want. It would help you graph it better. 0, 3. Now, I understand that this is a 4 and you don't know where 3 is. Well, 3 is just underneath 4. Okay? Approximate. 1, 12. 1, 12. 2, no, -1. Okay, don't freak. -1. This is between a half and a 1. Okay, it's 3/4 of the way up. Except this is a 4. This is 2, this is 1, so it's like right there. Okay, it's hugging the x-axis. 2, 48. 1, 2, 48. Looks weird, right? -2, barely above. And if you go -3, it's going to be an even smaller number. -4, even smaller. But it's never going to be negative. Okay, it's never going to cross that x-axis. So when you are graphing these, it's obvious that it curves like this. And it's going to be so close to the x-axis that it's just kind of thicker there, and that's all.
So we're not doing parabolas anymore?
It is not a parabola. It is never, ever going to come up. Never. Yeah.
Could it ever be 0 on the x-axis?
No.
It can't, there's no physical way to make it 0. Whatever number you put in, you're gonna get a whole number.
You're going to get a whole number every time. Okay, now, this is the same thing except we have a negative. What do you think is going to happen? It's going to go down. It's going to hug the x-axis up on top. Okay, somebody put a 0 in for me. What do you get?
2, 5.
-5. How about a -1?
10.
It's not 10.
-2.5.
A 1 is -10. Don't all of these have to be negative?
Mm-hmm.
Because the last thing you do is multiply by -5 and this is never gonna be negative.
Mhm.
Move me, make me positive, that's never gonna be negative. Okay, what about 2? Negative 20?
Negative 1.25.
Alright, so we gotta get down to negative 20. Let's count by 5s. You can count by anything you want. But it'd be stupid to count by 1s and then run out of room. And just, use some common sense. 5, 10, 15, I don't like to put them all in. 20, 5, 35, 45, good enough. Okay, 0, negative 5. Negative 1, negative 2.5. Well, 2.5 is halfway between 1 and 2. 0 and 1. No, I did something wrong.
0 and 5.
0 and 5, that's right. Okay, 1, negative 10. Now you can already tell where it's going to curve. It's going to come around this way. Okay, 2, negative 20. Seems like I should have spread them out a little more. And then negative 2, kids says to me, how do I graph that? $1.25. It's a little more than $1. It's less than $1.50. Okay, negative 2, negative 1.5. See what's going to happen is it's going to get closer and closer and closer and closer and closer and closer until it looks like it's on the x-axis, but it never really is. It might be as little as 1/1,000,000 of an inch there, but it's never going to cross it. And so you graph it, showing that it's getting closer and closer. That's it. Ready to try one? Don't throw away this graph paper, okay? There's 12 of them on here, so let's save them for another day.
So, what kind of story problems will these be?
Story problems are here is an exponential equation, x equals days. In 3 days, how many fleas are we going to have? It's really easy stuff. Because you get the equation, you get the x, all you do is plug it in.
But then we're not going to use negatives.
Huh?
Then we're not going to use negatives. Right?
Well, you can graph that, but I don't think I asked you to graph a story problem. You will in algebra 2.
Everyone I know sucks. If they didn't describe it, I think that's just how it is. How do I know that?
All right, first fill in your t-chart. We're going to do 3 times 1/2 to the x power. Plug in these 5 numbers, and then decide where you want your x-axis. And then decide how you want to number it. Doesn't matter now.
We're done
Yeah.
with those, right?
Wait, what are we doing?
I need some gum.
That one?
Do you want? I have some.
I bought some last night. I went to bed at 9 again.
Did you?
that bad?
That was good.
7 the night before.
Is that even better?
That's horrible.
You know it's gonna be hard. Is it
Feeling a lot better.
when the puppy
It's like 12 hours of sleep.
Oh, don't even tell me. It's like having a baby.
It is gonna be like
I
that.
have to get up and walk that dog before I get in the shower. Oh, shoot me.
Oh, did you get it already?
You bought it anyway.
I'm April 7th.
Okay.
Yeah, but
It's not forever, but
it's temporary, but
Oh,
it's
you
gonna
have
be
your
like a
dog?
baby.
April 7th. I'm gonna see him tonight though.
Oh.
I'm visiting.
Why can't you have it until April 7th?
If I'm going on spring break, I don't wanna screw him up.
Where are you going for
He's
spring
gonna be
break?
traumatized enough when he leaves his mother.
Where are you going for spring break this summer?
Baby. Oh, nice. I wish I would.
It's all
What
for
It's my 93rd trip.
I've only been there
What are you
twice,
gonna do for your
but
100th trip?
it's nice.
Take all of
Your
us.
93rd.
Take Larry.
That's a lot of time going to
Take all
Vegas.
24.
Live there. You should live
How
there.
old were you when you first went?
I was pretty old, 30-something.
What, in the year 9? So you go,
About 5 times a year.
The stoner. It's really stoner.
Does
It's
not
really
get
easy because you can plug it all in and then you click the back place and you can plug it in.
Yeah.
Oh,
Nice, that's cool.
I didn't even think of that.
What?
Except if it's a
What?
negative.
You can leave the equation there, just go back and put in a different number in.
Oh, yeah.
I didn't even think of that.
And if it's a negative and you're going to a positive, if you just go over to the negative, hit clear, it clears it.
Yeah, I was shooting.
Yeah, but
What did you wanted to Don something, what was it?
Huh?
What did you want?
Oh, keychain.
With Don on it.
With that,
No, you
that's
said
in
you
Vegas.
didn't get one. I didn't ask for it.
Hey, can I have a chain? Will you give me a chain? It says student of the month on it.
Oh yeah, I can't get taken out though. Just
Just say, it's right there, number 4. That's the neck.
Are we supposed to graph it or just keep
1
the
and 1/2.
T-chart?
Graph it. Okay, graph it.
You're a loner. Don't call him a loner. He's got better grades.
So
than you.
T-chart and graph. And when you have it finished, move on to the next one, we'll check it.
Yeah.
Oh, these are the ones that we check?
Yeah.
Yeah, you check.
Negative.
Do you want me to not keep recording then?
Do you want to turn the recording off?
So wait, is he
Oh, duh.
What you want?